Good afternoon, everyone. I'm Iman, and today's presentation is titled Measurements and Units of Analysis. We'll begin by viewing the outline of this presentation. So first, we will see the definition of measurements, then we'll cover the notions of reliability and validity. After that, we'll address the complexities in measurements. We'll explore the units of analysis and units of observation. Then we will see the difference between dependent and independent variables. And lastly, we'll define and understand extraneous variables and rival plausible explanations. So, let's start with the definition of measurement. Measurement is a systematic process of assigning numbers, symbols, or values to observations, objects, or events according to specific rules. It converts abstract concepts like intelligence or satisfaction into concrete quantifiable data, enabling statistical analysis and objective evaluation of variables. Before moving to the notions of reliability and validity, we need to address first measurement quality. Measurement quality in research methodology ensures that tools and techniques accurately and consistently capture the intended data. It is primarily defined by two core components, which are reliability and validity. First, let us start with reliability. Reliability ensures the instrument produces consistent results under similar conditions, which minimizes error. In short, reliability is about consistency, finding the same results over time or across different observations. On the other hand, the notion of validity is about ensuring the instrument measures the constructs it's supposed or aims to measure. In other words, validity is about accuracy. When talking about validity, we need to address internal validity and external validity. Here is a table summarizing what each type of validity concerns. This segment addresses the complexities in measurement. Measurement is a complex process, and some concepts are more complex than others. For example, measuring quality of life, financial security, or social anxiety. These concepts are difficult to measure because we simply don't have scientific tools or equations to measure them. To address these complexities, we will examine the various levels of measurement. But before, we need to address the notions of variable and attribute. A variable is a grouping of several characteristics, while attributes are those characteristics. The attributes of a given variable are what determine the level of measurement, of which there are four: nominal, ordinal, interval, and ratio. Starting by level 1, nominal measurement. Nominal measurement is the simplest, lowest level of data measurement, used to categorize variables into distinct and ordained groups or labels. These categories, such as gender or hair color, have no inherent numerical value, order, or ranking. Characteristics of nominal measurements are nominal data cannot be averaged, added, or subtracted. Numbers such as 1 for male and 2 for female are merely labels, not quantities. Examples include hair color, gender, yes-no responses, and geographical locations. The second level of measurement is ordinal. Ordinal measurement is a level of measurement that ranks data in a specific meaningful order, like first, second, third. While the order is clear, the intervals between values are inconsistent, unknown, or not equivalent. Characteristics of ordinal measurement include the ranking tells you if one item is higher or lower than another, but not by how much. It is a form of qualitative or categorical data that allows for ranking. Examples include ranking items by preference, socioeconomic status, such as saying low, middle, high socioeconomic status, and educational levels, such as saying bachelor, master, PhD, etc. The third level of measurements is interval. Interval measurements is a quantitative level of measurement that ranks data with equal known distances between adjacent points. This allows for calculation of means and differences, but it lacks a true zero point. Moving to characteristics of interval measurements, equal intervals, the difference between 10 and 20 is the same as the difference between 30 and 40. The zero is arbitrary. The 0 point is assigned for convenience and it does not represent an absolute lack of the variable. Examples include calendar years and IQ scores. The fourth level of measurements is ratio. Ratio measurement is the highest, most precise level of quantitative data measurement Ratio measurements is the highest, most precise level of quantitative data measurements, featuring ordered, equally spaced intervals and a true 0 point. This allows for meaningful calculations of ratios, such as stating one value is twice as much as another. Characteristics of ratio measurements include unlike interval data where the 0 point is arbitrary, 0 on a ratio scale actually means none of the quantity exists, for example saying 0 kilograms or 0 dirhams. Because of the true 0, we can compare measurements directly. For example, we can say 100 kilograms is twice as much as 50 kilograms. Examples include cars in a parking lot, time, and price. Here is a summary of the 4 levels of measurement. Levels of moving to units of analysis and units of observation. So a unit of analysis is the primarily entity, phenomenon, or level of social life that a study aims to understand or what claims about. It answers what or whom am I trying to explain. While a unit of observation is the specific source of data, the entity from which information is directly collected or measured. It answers what data points did I actually collect or measure. Let's see some examples. First example, in order to understand team productivity, you survey individual team members. So what you are aiming to explain or to analyze is team productivity. And what you observe is the individual team members. So the unit of analysis is team productivity, while the unit of observation is individuals. The second example is about determining which city has the highest crime rate. In order to do so, we look at police reports for each neighborhood. So what we aim to analyze is the level of crime rates in a city. And what we observe are the police reports. So the unit of analysis is cities, while the units of observation are the reports, the police reports. So in conclusion, the research question determines the units of analysis, while the method of data collection determines the units of observation. It is important to distinguish between the two because confusing them can lead to errors such as the ecological fallacy, which is about making inferences about individuals based on a group data, or a reductionism, which is explaining a more complex, broad phenomena too narrowly. This next segment concerns independent and dependent variables. An independent variable is a variable that causes another variable. It is the factor manipulated or changed by the researcher to test the effects. While a dependent variable is a variable that is caused by another variable. It is the outcome measured which changes in response to the independent variable. Let's take a look at some examples. The first example, Does caffeine improve test scores? This is our research question to figure out whether or not caffeine improves test scores. So the independent variable would be the amount of caffeine consumed, while the dependent variable will be the test scores of students. The second example is how does sleep affect memory? So this is our research question, is to figure out how does sleep affect our memory. So the independent variable will be the hours of sleep, and the dependent variable will be the memory to figure out the results of tests of a memory. Now we'll move to extraneous variables. An extraneous variable is any factor in a research study that is not the independent variable but has the potential to affect the dependent variable. For example, in a research on the effect of a new study technique on exam scores, the students' existing IQ level or amounts of sleep before the exam are extraneous variables that could affect the results. So in this, the independent variable is the technique, the new study technique. The dependent variables will be the exam scores, and the extraneous variables would be the student's existing IQ level or amount of sleep before taking the exam. So an extraneous variable can impair the research by acting as a nuisance variable, meaning that it is not the focus of the study, but it can affect results. It can threaten the validity of the research. If it is not controlled, it becomes difficult to determine if the outcome came from the independent variable or the extraneous variable. And lastly, it can become a confounding variable, which completely distorts the relationship between variables. There are methods to control extraneous variables, such as standardization, which is to keep conditions consistent for all participants. Another method is randomization, which means randomly assigning participants to groups to distribute characteristics evenly. And the third method I'm going to mention is blocking or matching, which is about ensuring groups are matched on specific variables such as age or experience. Next is rival plausible explanations. A rival plausible explanation is an alternative interpretation, factor, or variable that could account for study results rather than the hypothesized cause. For example, patients in a hospital improved over time naturally, not because of the treatment. Or for example, an external event such as weather news, a policy change occurring during the conduction of a study. So a rival plausible explanation can impair a study by competing with the researcher's hypothesis to explain the dependent variable. It can also threaten the validity of the study. If it is not ruled out, rival plausible explanations can make it impossible to determine if the intervention actually worked. There are, of course, methods to eliminate rival plausible explanations, such as randomizing trials to balance unknown confounding variables, or using triangulation, which is to combine multiple methods of researchers or data resources to confirm findings and reduce bias. The researcher can also document potential alternative explanations and provide empirical evidence that disapproves them. So, to conclude, measurement is a complex systematic process of assigning numbers or values to observations and events according to specific rules. There are 4 levels of measurement: nominal, ordinal, interval, and ratio. Units of analysis concern what the researcher is trying to explain, while units of observation concern the data the researcher collects or measures. Thank you for watching, and I'll see you another time.